Ever think about what actually keeps a huge airliner running up there? Or, even a little drone buzzing around. It's not just the engines roaring or the rotor spinning. There's this hidden power source, absolutely essential. It keeps everything going, from cockpit displays to emergency lights. And increasingly, it's even involved in the propulsion itself, especially when the main engines are off, or, well, when there aren't any engines at all. We are talking about aircraft batteries. And believe me, this isn't just about giving a quick spark to start an engine anymore. Not at all. This is a market that's evolving incredibly fast. It's high stakes, powering critical systems, providing that vital emergency backup, literally life-saving stuff, and it's becoming totally central to the future of electric flight. So our mission here is to take this pile of source material you've got and really pull out the key trends, introduce you to the big players dominating the space, and maybe uncover some surprising insights shaping this critical high-tech industry. Think of this as your shortcut, your inside track to understanding what's really going on in the aircraft battery market.
And looking at these sources, yeah, what immediately jumps out is just the sheer momentum. This market is really moving.
Momentum is definitely the word. The numbers in the source material paint a really clear picture. It's valued at what, USD 412.9 million in 2024?
That's right.
And it's projected to absolutely soar to nearly 1.2 billion USD, 1,194.5 million by 2032.
Wow.
That's a compound annual growth rate of 14.2%. I mean, for context, that is incredibly strong growth for any aerospace component market. Seriously strong.
Yeah, and you don't see that kind of growth without some pretty fundamental shifts happening underneath. The drivers the sources highlight are pretty significant. There's the ongoing electrification of aviation systems just across the board.
Right.
Then you've got some really quite remarkable advancements happening in battery technologies themselves. And crucially, the increasing adoption of electric and hybrid electric aircraft platforms. That's a big one.
Yeah, it's that push towards what they call more electric aircraft, or MEA. That, combined with this rising demand for power sources that are like both lightweight and high density, packing a lot of punch into a small, light package, that seems to be really speeding things up.
Exactly right. It all ties back to those big goals the aircraft manufacturers are laser focused on. Reducing dependency on fossil fuels, slashing carbon emissions, and cutting down those maintenance costs.
Yeah.
Advanced battery systems aren't just like a nice-to-have feature anymore. They're essential tools for hitting those targets.
The source also notes that the demand isn't exactly the same everywhere. It kind of varies depending on the segment you're looking at. Like, commercial aviation is prioritizing batteries for things like sustainable operations and those emerging regional electric aircraft we're starting to hear about.
Well, in the military sphere, batteries offer some really unique advantages. Think about enhanced operational flexibility or maybe critical silent flight capabilities for surveillance or special ops, that kind of thing.
Interesting.
Geographically, it seems like North America and Europe are really leading the charge in developing these electrified platforms. They're leveraging their established aerospace ecosystems. Meanwhile, Asia-Pacific is focusing heavily on modernizing infrastructure to support, greener aviation initiatives.
Okay, let's maybe unpack this a bit. With stakes this high and growth happening this fast, getting a battery actually approved for use on an aircraft, that sounds like it's not trivial at all. What actually makes a battery good enough to fly? What are companies really competing on beyond just, raw power?
Oh, it goes way beyond just holding a charge or delivering amps.
Yeah.
Way beyond. The sources details some absolutely crucial criteria, and they really speak to the unique unforgiving nature of aviation. So innovation in battery chemistry is obviously fundamental, but perhaps even more critical is just stringent safety compliance.
Right.
Aviation standards are incredibly demanding. We're talking regulations like DO311A, DO160, plus extensive FAA requirements. Batteries don't just need to meet these. Sometimes they need to flat out exceed them.
Right, makes sense. Because when you're miles up in the air, failure of a critical system is, well, it's just not an option. So safety under extreme conditions, thinking about radical temperature swings at different altitudes, pressure changes, constant vibration, that must be absolutely paramount.
Paramount is the right word, absolutely. And you add to that energy density, basically how much electrical energy you can cram into a given volume or weight, and also life cycle performance. That means how many times you can reliably charge and discharge the battery over its working life without it, degrading significantly.
And that energy to weight ratio, the source actually calls it a defining factor. Why is shaving off every possible gram so important up there?
Well, because in aviation, weight translates directly 1-to-1 to fuel consumption.
Mm.
A lighter aircraft is simply a more efficient aircraft.
Hmm.
So designers are in this constant battle, always looking to reduce weight wherever they possibly can, but without compromising power or, critically, safety. So a battery that delivers the needed power or energy density but weighs less, that's a major, major competitive advantage.
Fascinating. So it really is this delicate balancing act. Power, weight, safety. What else matters? What else are they judged on?
Well, other key factors that companies are really evaluated on include things like adaptability across different types of aircraft platforms, overall battery efficiency, modular design options, which makes integration and maintenance easier, and the ability to integrate seamlessly with what are called battery management systems, or BMS.
Okay, BMS. What does a battery management system actually do?
Think of the BMS as the brain of the battery system. It's constantly monitoring things like voltage, current, temperature for every single cell within the battery pack.
Okay.
It manages the charging and discharging process to optimize performance and extend the battery's lifespan. And maybe most importantly for aviation, it incorporates predictive diagnostics and smart charging interfaces, and it manages all the safety protocols, detecting potential faults before they can become critical problems. Features like redundancy and automatic fault detection are highly, highly valued. They're built right into the system design.
Got it. So it's not just the battery cells themselves, but this whole intelligence system around them, making sure they're safe, healthy, and communicating with the rest of the aircraft.
Precisely. These integrated features and this kind of robust performance are particularly critical for the really demanding applications. Think commercial airliners, business jets, the drone market, which is just exploding, and that next generation of urban air mobility UAM vehicles. Those electric vertical takeoff and landing aircraft, the EV tools you hear about.
Right, the air taxis.
Yeah. And beyond the tech itself, companies also need really robust R&D pipelines, vertically integrated manufacturing that helps with quality control and strong, long-standing partnerships with the big aerospace OEMs, the Airbuses, the Boeings, but also newer players like Joby Aviation, Embraer, plus defense contractors, and of course, absolutely non-negotiable, those certifications from aviation authorities we talked about. Can't fly without them.
Okay, so given those incredibly tough criteria and the need for these deep industry connections, who are the big players? Who does the source say has managed to build that kind of dominance in this space?
Yeah, the source points to 5 specific key players who currently lead the market. These are companies with generally long histories in aerospace: EnerSys, Saft, Concorde Batteries, Teledyne Battery Products, and EaglePicher Technologies.
Okay, let's maybe break those down a bit. Who's leading the pack right now and what's their specialty?
So EnerSys is out front. They lead with a significant 18.5% market share, according to the source. Their strength really lies in established, proven technologies like nickel-cadmium 9C and valve-regulated lead-acid, or VRLA, batteries.
Kind of the older tech, but reliable.
Exactly. In a risk-averse industry like aviation, that reputation for high reliability and really robust design, especially under tough conditions, that's a major plus. They've got strategic supply contracts locked in with major OEMs and defense agencies, really leveraging those long-standing relationships.
Okay. And following them pretty closely is Saft, which is actually a subsidiary of Total Energies.
That's right. Saft holds a significant 15.2% share. They're known for high-performance lithium-ion, ion, but also nice-seed batteries. So they cover a couple of bases. They provide critical power for main aircraft systems, emergency backup power, and also auxiliary power units, the APUs.
Uh-huh.
You find Saft batteries widely adopted in commercial airliners, business jets, helicopters, rotary wing aircraft globally. Their expertise across different chemistries definitely gives them breadth.
And Concorde Batteries, what's their niche?
Concorde has a respectable 12.5% share. They've really built their reputation on premium sealed lead-acid batteries. You see them used extensively across general aviation, smaller planes, but also military and commercial sectors too. Their trusted position comes from delivering really durable, low-maintenance batteries that consistently meet those tough FAA and military specs. People value them for reliability and pretty straightforward replacement.
Okay. And Teledyne Battery Products. They're part of the larger Teledyne Technologies group.
Yep, Teledyne holds 10.4% of the market. They're known for their Aero battery line, offering both niacinated and lead-acid types, specifically designed for aerospace and defense. You'll find their batteries in commercial transport aircraft, business jets, and also UAVs. Their particular strength is performance and durability in really demanding conditions, like high vibration and high-altitude environments.
Right. And rounding out this top group, EaglePicher Technologies.
EaglePicher secures about 8.2% share. They are really recognized for highly specialized battery solutions. That includes both primary, meaning non-rechargeable, and rechargeable systems, often for very specific, demanding aerospace and defense needs. Their products get used in really challenging applications, things like fighter jets, helicopters, even space launch systems. Places where you need custom-designed batteries to meet unique performance requirements, like under high altitude or high G-force conditions.
Wow. Okay, so it sounds like these five have really cemented their positions over many years, often focusing on that proven, reliable chemistry and leveraging existing relationships in a market where, yeah, reliability is just everything. But the source also mentions, this market is moving incredibly fast. New technologies are coming online. Are there companies challenging this established order? Are there disruptors?
Oh, absolutely. The source definitely identifies a group of companies that are increasingly positioning themselves as competitive threats to these long-standing leaders. This group includes names like Yuasa Corporation, Marathon or Fark Aerospace, Mid-Continent Instruments, and Avionics, particularly their True Blue Power division, and also Lithium Works.
Interesting. So how are these maybe newer or less dominant players managing to actually challenge the incumbents? I mean, the incumbents have such deep roots and those critical certifications already locked down.
Well, they're coming at it from a few different angles, really. Some are leveraging advancements in newer battery chemistries, like lithium-ion variants, and focusing on improved safety systems for those chemistries.
Well,
Others are focusing intensely on meeting or maybe even accelerating the certification compliance path for these newer technologies. That's a huge hurdle.
yeah.
Targeted innovations for specific market segments like the eVTOL space, strategic collaborations, often with newer aircraft startups, and expanding their international footprints. Those are all part of the playbook, too.
Can you give us maybe some specifics on how a couple of these challengers are making their move?
Sure. Take GS Yuasa Corporation. They're based in Japan. They're leveraging their really extensive experience in energy storage from other industries, automotive, industrial, and making inroads now with high-performance lithium-ion batteries for both commercial and military aircraft.
Yeah.
They're known for having pretty robust R&D capabilities.
Okay. And Marathon or Kako Aerospace.
They're a U.S.-based company, known for reliable, kind of rugged batteries. While they've definitely worked with aniseed and sealed lead acid in the past, they're putting an increasing emphasis now on Li-ion. They have a diverse portfolio and already have some long-standing relationships with major aerospace OEMs, which gives them a platform to introduce newer tech to established customers.
And you mentioned the True Blue Power division of Mid-Continent Instruments and Avionics seemed notable.
They really are. They're generally known for innovative avionics and power solutions, but they've gained a lot of attention specifically for their FAA-certified lithium-ion batteries.
Ah, FAA certified Li-ion. That's key.
Exactly. They're really highlighting the high energy density, the long life, the low maintenance aspects of their batteries. And those features attract not just traditional manufacturers, but importantly, they're attracting the developers of emerging electric aircraft and eVTOLs, who are actively looking for those cutting-edge power solutions right now.
Makes sense. And Lithium Works. You said they're known for specific chemistry?
That's right. They specialize in lithium iron phosphate chemistry, often abbreviated as LiFePO4 or LFP. This is generally seen as a potentially safer, more thermally stable alternative compared to some other types of lithium-ion chemistries.
Okay, safety focus.
Yeah, so their batteries are increasingly being considered for things like UAVs, urban air mobility vehicles, and other next-gen platforms where safety and long cycle life are absolutely paramount concerns. It's a slightly different value proposition than maybe the highest possible energy density.
Gotcha. So it really sounds like the established players kind of built their dominance on proven tech and relationships, like we said, while these challengers are trying to disrupt things with newer chemistries, often targeting that future of electric flight more directly. Looking ahead then, what does the source say about where this whole market is heading? What's the future look like?
Well, the source really stresses that the global aircraft battery market is undergoing what it calls a pivotal transformation. No exaggeration there, I think.
Yeah.
And this is driven by those big macro trends we touched on earlier. The broader aviation sector's really intense push for decarbonization, the increasing electrification of almost all aircraft systems, and that constant drive for greater operational efficiency. Less fuel burn, less maintenance.
And that clearly means the demand for advanced batteries, the ones with high energy density, lightweight construction, really strong safety credentials, that demand is only going to continue its steep climb, right?
Absolutely. The source highlights that companies simply must adapt quickly to emerging trends. It specifically points to potentially revolutionary battery chemistries like solid-state batteries and lithium-sulfur batteries as key areas for the future.
Solid state and lithium sulfur.
Yeah, these promise even greater energy density, maybe even better safety in some cases, but they definitely come with their own pretty significant set of development and certification hurdles to overcome.
So what kind of investments does that really require from companies that want to stay ahead of the curve here?
Well, significant investment in next-generation material science is crucial. You need the fundamental breakthroughs, as is advanced fail-safe design engineering, getting back to that critical safety piece we keep mentioning.
Uh-huh.
And scalable manufacturing capabilities are also key. You need to be able to produce these advanced batteries reliably and in volume to meet that projected demand.
And collaboration seems like it would be essential too, right? Given the complexity.
Critically important. The source emphasizes this. Partnerships with the established aerospace OEMs, with the nimble electric aircraft startups, and also with research institutions, universities, national labs, all of that is seen as vital. It's
Right.
about accelerating innovation, but also, crucially, navigating and ensuring compliance with aviation's extremely rigorous regulatory landscape. You can't do it alone.
Yeah, it sounds like a really complex mix of like cutting edge material science on one hand and navigating some pretty significant bureaucratic hurdles on the other.
It really is. And one more point the source makes is about expanding global footprints. Using localized production and service partnerships is noted as a strategic advantage. This helps ensure supply chain resilience, something everyone's thinking about more these days, and it positions companies better to meet that increasing global demand, especially as electric aviation platforms start to roll out more widely.
So ultimately, it sounds like the source concludes that the companies best positioned to really lead this next chapter of growth are going to be the ones that can successfully prioritize that cutting edge innovation, achieve and maintain those crucial certifications, and develop solutions that are really, truly aligned with what their customers need. Whether that customer is flying a traditional airliner or one of these futuristic eVTOLs. Wow. Okay, we have covered a lot of ground here. We started with understanding the massive market momentum, the sheer value of aircraft batteries today. Then we dove into those incredibly demanding technical criteria that make this market so unique: the safety, the weight, the density. We met the established players, the ones who built dominance on proven reliability over decades. And then we saw how these agile challengers are really pushing the envelope with newer technologies, specifically targeting the future of electric flight. It really gives you a much deeper insight, I think, into not just the components powering aircraft, but the whole infrastructure that's needed for cleaner, more efficient air travel in the years ahead.
Absolutely. And, as the source points out, the critical importance for companies to adapt quickly to embrace these potentially revolutionary new battery chemistries like solid state and lithium sulfur for future growth. It does raise an interesting question. It's maybe something for you listening to consider. How quickly can this kind of truly revolutionary innovation actually happen and become widely adopted in a market where fail-safe design engineering isn't just, a goal, but an absolute non-negotiable requirement, especially when it's governed by these incredibly stringent and often quite slow-moving safety and certification standards? What does that inherent tension between the speed of innovation and the absolute need for safety really mean for the future pace of change in flight?